Hi, my name is Muhammad Daniel Shah bin Hadi. So today we're gonna exploring polymerization method for polyethylene, presented by Abdul Jabbar bin Kamal and Nakib Adli bin Muhammad Nazri and me, Muhammad Daniel Shah bin Hadi. Let's go. As introduction, polyethylene (PE), versatile synthetic resin made from the polymerization of ethylene. Polyethylene is a member of the important family of polyolefin resins. Polyethylene was being produced by polymerization of monomer ethylene. It is the most widely used plastic in the world, being made into products ranging from clear food wrap and shopping bags to detergent bottles and automobile fuel tanks. It can also be slit or spun into synthetic fibers or modified to take on the elastic properties of a rubber.
Right, Assalamualaikum. I will present the first polymerization method for polyethylene, which is bulk polymerization. Bulk polymerization is one of the popular process for producing polyethylene (PE), a thermoplastic polymer. In this procedure, ethylene monomers are polymerized in a single-phase solution without the need of a solvent to create polyethylene. Okay, bulk polymerization requires a few crucial processes. The first one is initiation. The initiation stage, which involves introducing an appropriate initiator into the system, kicks off the process. Compounds known as initiators are those that disrupt a chemical link to release free radicals. Common initiators for polyethylene bulk polymerization are azo compounds or organic peroxides. These initiators decompose under certain conditions, generating free radicals that initiate the polymerization reaction. The second one is propagation. The ethylene molecules react with the free radicals once they are initiated. Hydrocarbons like ethylene have a double bond between carbon atoms. A chain reaction involving the ethylene monomers is brought on by the radical attack on this double bond. The polymer change lengthens as more and more ethylene molecules are added to it during propagation. The third one is termination. Up until termination events take place, the polymerization reaction keeps going. The interaction of two free radicals causes termination, which halts the formation of a polymer chain. Disproportionation termination and combination termination are two examples of the various termination process. Number four is polymerization conditions. Usually, bulk polymerization is carried out under high pressure and temperature conditions. Elevated temperatures facilitate the disruption of carbon-carbon double bond inside ethylene monomers, hence enhancing their reactivity. In order to prevent the creation of a gas phase and to retain the reaction in liquid phase, high pressures are maintained. Okay, number five is polymer recovery. Recovery of the resultant polyethylene from the reaction mixture occurs when the polymerization reaction is finished. The polymer may be solidified by cooling the mixture, and then the final polyethylene product may be obtained by further separation and processing. Next, number six, additive and stabilizers. To improve the polyethylene qualities or prevent it from degrading during usage or manufacturing, a variety of stabilizers and additives can be added. Antioxidant, UV stabilizers, and processing aids are a few examples of these additives. Alright. Next, I will talk about advantages of bulk polymerization. The first one is simplicity and cost effectiveness. Uh, For this point, the bulk polymerization is a relatively simple process, making it cost effective for the production of polyethylene. It doesn't require a solvent, which reduces equipment and operational costs. So the cost will be effective. Uh, Number two is high conversion rates. Bulk polymerization typically achieve high conversion rate, meaning a large percentage of the monomers are successfully converted into polymer. This contributes to higher overall efficiency in the production process. Number three is high purity of polymer. Since there is no solvent involved, the resulting polyethylene often has high purity. This is advantageous in applications where impurities can negatively impact the polymer's properties. The fourth advantages for bulk polymerization is reduced environmental impact. The absence of solvents in bulk polymerization reduces the environmental impact associated with solvent handling, disposal, and recovery processes. It is considered a more environmentally friendly option compared to some other polymerization methods. Alright, next I will explain about disadvantages of bulk polymerization for polyethylene. The first one is heat management challenge. The high temperature required for bulk polymerization can lead to challenges in managing heat within the reaction system. Heat removal becomes crucial to prevent undesired side reactions or degradation of the polymer. Number two is limited control over polymer morphology. The lack of a solvent in bulk polymerization can result in limited control over the polymer morphology, including particle size and structure. This may affect the mechanical properties of the final polyethylene product. Number three is high energy consumption. The elevated temperatures and pressures needed for bulk polymerization require substantial energy input. This can contribute to higher energy consumption and associated operational costs. Number four is potential for gel formation. Bulk polymerization may be prone to the formation of gel particles, which are undesirable agglomeration of polymer. Gels can affect the polymer's mechanical properties and processing characteristics. For the example of product and application for bulk polymerization is the first one is film and sheet production, containers and bottles, and pipe fittings.
For solution polymerization involves dissolving monomers in a solvent to form a polymer solution. In polyethylene production, this method often uses liquid hydrocarbon as solvent. Process steps. First, monomer dissolution. Gaseous monomer are dissolved in the liquid hydrocarbon solvent to create a monomer-rich solution. Catalyst introduction. Catalysts are introduced to initiate the polymerization reaction. Polymerization. The polymerization reaction takes place in the solution, forming polyethylene chains. Fourth is product recovery. After polymerization, the product is recovered by removing the solvent, often through process like evaporation or steam stripping. For key principles and conditions, precise temperature control and the use of catalysts are crucial. The solvent choice impacts the reaction rates and polymer properties. So, the first key is use of catalyst. Initiation of polymerization, control over reaction catalyst selection. Precise temperature control, temperature influence, and thermodynamics. Solvent choice, its effect medium for polymerization, impact on reaction rates, and polymer properties. For advantage, better control over polymer properties. This is because tailored characteristics and customization. Second is high purity and uniformity. This is because homogeneous reaction medium that used in this process and it reduce impurities. Third is suitable for various polyethylene types because for the versatility and wide application range. For disadvantage, energy intensive due to solvent removal. First is solvent evaporation, second is resource consumption. For environmental concerns related to solvent usage. This is because for the emission and disposal and regulator compliance. For daily usage, there are various examples such as water bottle, pipe, PVC, Tupperware, and toys also. So that's for daily usage.
Assalamualaikum. My name is Muhammad Akib Adli. Okay, let me introduce you to immersion polymerization. Okay, what is immersion polymerization? Immersion polymerization is a type of radical polymerization process where monomer are dispersed in an aqueous phase to form an emulsion. This method produces polymer particle, typically in the form of latex, which is a stable colloidal suspension of polymer particle in water. Before that, we need to know that emulsion polymerization are not commonly used method for producing of polyethylene, but it's okay. Let me show you the step of emulsion polymerization. Okay. Firstly, initiation. Water soluble initiator such as peroxide or persulfate are used to generate free radical in the water phase. Second, formation of micelle. Surfactant are added to stabilize the monomer droplet in water, forming micelle. The surfactant have a hydrophilic water-retaining head and hydrophobic water-repelling tail, which help to stabilize the monomer droplet. Third, monomer emulsification. Monomer are emulsified in the water phase within the stabilized micelle. Fourth, polymerization. The initiation of free radicals start the polymerization of monomer within the emulsified droplet. As polymerization proceeds, the monomer droplet grow into the polymer particle. Fifth, coagulation and particle growth. The polymer particle continue to grow, and as they reach a certain size, coagulation may occur. Coagulation involves the merging of particles to form larger particles. Six, termination. The polymerization reaction stops when the monomer is consumed and the free radicals are terminated. Seventh, recovery. The latex polymer is often stabilized with additional surfactant or stabilizer to prevent coagulation during storage. The latex can be concentrated and any unreacted monomer, surfactant, or apparatus are removed. Let's take a look on the essential principle and factor involved. Immersion polymerization is a polymerization process with different applications on the industrial and academic scale. It involves application of emulsifier to emulsify hydrophobic polymer through aqueous phase by amphithetic emulsifier, then generation of free radical with either a water or oil solution soluble initiator. This is the advantage of immersion polymerization. Firstly, particle size control. Immersion polymerization allows to precise control over particle size and distribution, potentially resulting in a uniform polyethylene particle. Second, potential environmental benefit. Immersion processes often use water as a medium, potentially reducing the use of organic solvent, which could be more environmentally friendly. Then the disadvantage, firstly, challenge in emulsification. Emulsifying hydrophobic polyethylene in water might be highly challenging and might require a complex and expensive process to achieve stable emulsion. Second, process complexity and cost. Developing a process to emulsify the polyethylene could be significantly more complex and costly compared to other established polymerization methods. Emulsion polymerization commonly used as water-based coating. It is providing improved addition, flexibility, and barrier properties in water-based paint formulation. The second one is paper coating. It is enhancing water resistance and surface characteristic in paper coating, making them more durable. Okay, let's take a look on suspension polymerization. What is suspension polymerization? Suspension polymerization is a technique used to produce various types of polymer by dispersing monomer droplet in a continuous phase, usually water, with a add of a suspending agent and polymerizing them to form polymer particle. Okay, this is the method step. Firstly, monomer preparation. Ethylene, the monomer of polyethylene, is prepared and purified for use in the polymerization process. Second, initiation. Initiation, initiation. Second, initiation. Initiator, such as peroxide, are introduced into a reactor vessel containing the monomer suspended in a liquid medium, often water. This initiator generates radical and active sites necessary for the polymerization reaction to start. Third, polymerization, the ethylene monomer molecule start to react with the active site generated by the initiator. As these molecules link together, they form long chain of polyethylene. Fourth, suspension and stabilization. During the polymerization process, the during the polymerization process, the formed polyethylene particle remain suspended in the liquid medium of water, added by suspending agent or stabilizer. This additive prevent the polymer particle from aggregating and sticking together, ensuring uniform particle size. Fifth, termination. Eventually, the polymerization reaction slow down, leading the termination of chain growth. This happens as monomer are consumed or as active site become deactivate, resulting the information of polyethylene particle of desired size. What is suspension polymerization fundamental aspect? In suspension polymerization, monomer droplet with dissolved initiator are commonly dispersed in water. As the polymerization progresses, the droplet are transformed into sticky, viscous monomer polymer particle that finally become irregular spherical polymer particle of size 50 until 500 micrometer. What is the advantage of suspension polymerization? Firstly, particle size control. Suspension polymerization theoretically allows for controlling particle size, potentially resulting in uniform polyethylene particle. Secondly, potential for unique properties. Polyethylene produced through suspension polymerization might have distinct properties suitable for specific application due to its structure or particle size distribution. Next, the disadvantage. Firstly, complex process development. Developing a suspension polymerization process for polyethylene might be highly complex due to its hydrophobic nature, requiring extensive research and development. Next, challenging in suspension stability. Achieving and maintaining stable suspension of hydrophobic polyethylene particle in an aqueous medium could be difficult, impacting process efficiency. Suspension polymerization of polyethylene commonly produce cross-linked polyethylene PEX and apply in plumbing system. For more information, PEX is a form of polyethylene that is cross-linked using method involving suspension polymerization. While not the most common silent grafting or moisture-initiated cross-linking method can utilize suspension polymerization to produce PEX. In this process, polyethylene particles are suspended in a solution, and a cross-linking agent is introduced to form covalent bond between the polymer chains, enhancing the polymer properties.
Number 5 is gas phase polymerization. Gas phase polymerization involves polymerizing monomers in the gaseous state. It occurs in a fluidized bed reactor, where the monomers, catalyst, and additive are in a fluid-like state. Let's go to the process overview. First is fluidized bed reactor. Gas phase polymerization occurs in a fluidized bed reactor. The reactor has a chamber for gaseous reactant. It contains a pad of solid particles, usually polymer sheets or support materials. Second is monomer in gaseous state. Monomers like ethylene, used for polyethylene, enter the reactor in a gaseous form. Gaseous monomers move through the fluidized bed in the reactor. Fluidized bed dynamics. Fluidization. Continuous gas flow fluidize the bed of solid particles in the reactor. This fluidized state makes particles act like a fluid. Improved mixing and contact between monomers and catalysts occur in the dynamic environment. Next is catalyst production. Catalysts often support on solid particles, aid in polymerization. The fluidized bed efficiently distribute the catalyst throughout the reactor. Next is polymerization reaction. Initiation and growth. Monomer catalysts contact trigger polymerization. Polymer chains grow, sticking to the solid particles in the fluidized bed. Next is continuous process. Gas phase polymerization is a continuous process. New polymer chain grow, and existing ones circulate within the fluidized bed. Let's go to the core principle and condition involved in the gas phase polymerization. First is temperature. This is the critical parameter and optimal range. Second is continuous heat removal. Importance. This involve mechanism and prevention of term gradients. Third is pressure. This is significant. We must take care of pressure control and pressure drop. Fourth is process control. This is easy because right now we got automated system and feedback mechanism, and this involve process stability. And the last one is catalyst activity. Initiation of polymerization and involve catalyst selection, control over polymer characteristic. So that's why this is core principle. So for the advantage and disadvantage, for advantage, high productivity, and for disadvantage, it is limited control over polymer structure. And the second advantage is reduced energy consumption, and for the disadvantage, product quality challenge. There are variety application example such as food packaging, PVC pipe, laminating paper, and for botanical plastic bag.
Okay, now we will go through the comparative analysis section. Okay, there are several differences between these five polymerization method. For the bulk polymerization, uh, ethylene monomers are polymerized in a single phase solution without the need of a solvent. For the solution polymerization, dissolving monomers in a solvent to form a polymer solution. Emulsion polymerization, a type of radical polymerization process where monomers are dispersed in an aqueous phase. For suspension polymerization, the dispersing monomer droplets in a continuous phase, usually water with the aid of a suspending agent. For the gas phase polymerization, it is a polymerizing monomers in the gaseous state. Alright, in this section, I will tell you the strengthness and weakness in bulk, emulsion, solution, suspension, and gas phase polymerization. The strengthness for bulk polymerization is simplicity and cost effectiveness, high conversion rate, high purity of polymer, and reduced environmental impact. The weakness is heat management challenge, limited control over polymer morphology, high energy consumption, and potential for gel formation. The strengthness for emulsion polymerization is particle size control, potential environmental benefits, and possibility of new application. The weakness is challenge in emulsification, process complexity and cost, and also yield and efficiency. For the solution polymerization, the strengthness is better control over polymer properties, high purity and uniformity, and also suitable for various polyethylene types. The weakness is energy intensive due to solvent removal and environmental concerns related to solvent usage. For the suspension polymerization, the strengthness is particle size control, potential for unique properties, and possibility for specific application. The weakness is complex process development, challenge in suspension stability, and also product properties. For the gas phase polymerization, the strengthness is high productivity and reduced energy consumption, and the weakness is limited control over polymer structure and product quality challenge. Okay, in summary, the choice of polymerization method is tailored to meet the specific requirements of the end-use application. Bulk polymerization is cost-effective and suitable for common applications, while solution and emulsion polymerization offer better control for application requiring specific properties. Suspension and gas phase polymerization are advantageous for large-scale commodity production and specialty grades. Respectively, the selection involves a balance between the desired polymer properties, production efficiency, and economic consideration.
In conclusion, having a thorough understanding the polymerization technique used in the polyethylene sector enable producer to streamline workflow, create products that are specifically suited to their needs, effectively manage resource, guarantee product quality and safety, and support environmentally sustainable practice. This information is critically to the polyethylene industry sustained expansion and competitiveness in a world market that is changing quickly. That's all from us. Thank you very much for watching and Assalamualaikum.